Hey, welcome back, everybody. For the homework for tonight, I'd like to focus on number 4, and specifically I want to go over A and B on part 4. Number 4 talks about a biology project that Talisha is doing, and she's studying the growth of beetle populations. I know this is difficult to read, but you have to look off it off your own book. She starts her experiment with 5 beetles, it says, which, as we know, is going to be the y-intercept because it's the starting point. The next month, she counts 15 beetles. Parts A and B ask us to assume that this relationship is either linear or exponential. With only 2 data points, only knowing that she started with 5 and after 1 month there were 15, we have no way of knowing whether it's growing linearly, gaining 10 every month, or if it's growing exponentially, multiplying by 3 every month. We don't know exactly what the pattern is because we only have 1 month to judge it off of. So what A asks you to do is, suppose the beetle population is growing linearly. So imagine that it's a linear relationship. How many beetles can Talisha expect to find after 2, 3, and 4 months? So what I would recommend doing on part A is to make a table showing months 0, 1, 2, 3, and 4 as if it was a linear relationship. Part B is the exact same question, only it says assume that the population is growing exponentially. And we know that if it's exponential, then it's actually going to be multiplying. So I'm going to set up those tables, and that'll be the extent of my work that I do for today. So I'm going to put number 4 here. In part A, I'm going to make a table assuming that the relationship is linear, just like the problem asked me to do. So over here, I'm going to put months, because I know that time variable is going to be my independent variable. And then I'm going to put number of beetles as my independent variable. I know that months is controlling the number of beetles. So that being said, I'm going to start at 0. And the problem told me that initially, right when she started the experiment, she had 5 beetles. Then after 1 month, she counted and she had 15. That's the only information that they gave me. From there, I need to fill in months 2, 3, and 4. Now, remember on part A, they asked me to assume that this relationship is linear. If it's linear, then it's got to be adding by something. And here I see that the pattern or the change that's happening is 10 is being added to 5. 5 plus 10 is 15. Since it's linear, I know that's going to be an adding pattern. So to find month 2, all I need to do is add 10 to 15, and we know that that's 25. Then working our way down, we'll just continue to add 10 as we go down. So I have assumed that the equation is linear, or that the relationship is linear, and completed months 2, 3, and 4 as if it was linear. Now, in part B, they say, assume that the relationship is exponential, and fill in the table for months 2, 3, and 4. So I'm going to set up the same table. And I'm going to insert the same 2 points that they gave us. They said we start with 5, and after 1 month we have 15. The only difference here now is instead of following an addition pattern, I'm going to follow a multiplication pattern. And I know 5 times 3 equals 15. So I'm going to use the pattern times 3. So assuming that it's times 3, in order to fill in month 2, I need to take 15 times 3. And I know that that is 45. And then as I continue down, for month 3, I need to take my previous month's value, which is 45, and multiply that times 3. And I know that is 135. For month 4, I'm going to follow the same pattern, multiply by 3, and I know that that is 405. So we don't know, based on the information we have, whether it's linear or exponential, but I can fill in the table following both. The linear table having a slope of 10, and the exponential table having a growth factor of 3. And then part C, they asked me to write an equation for this relationship. D, write an equation for this relationship, which you all have the tools to do. So that's my help for tonight. Good luck on it, and we'll see you tomorrow in class.